Hello, dear students. This is your engineering mathematics 3 lecture. Today we are going to start second unit. The second unit is the topic is Fourier transform. Fourier transform. This concept is from Fourier integral theorem. See what is Fourier integral theorem. If a function f of x is such that if there are two conditions, f of x satisfies Dirichlet's condition, and second one, f of x is absolutely integrable. Absolutely integrable means integration from minus infinity to infinity mod of f of x dx converges. Then we can represent f of x as integral. That integral equation 1 represents the integral of the function f of x. Now, what is Fourier transform? The concept of Fourier transform. The function f of lambda, that f is capital F, f of lambda is equal to integration minus infinity to infinity, f of u e raised to minus I lambda u du is called as Fourier transform of the function f of x. You know what is the function f of x? The function f of x which is absolutely integrable and it satisfies Dirichlet's conditions. That function is f of x. And f of x is equal to 1 upon 2 pi into integration minus infinity to infinity f of lambda into e raised to minus I lambda x d lambda is called as inverse Fourier transform. So this is the formula for inverse Fourier transform, and the first one is capital F of lambda. This is equal to integration or minus infinity to infinity f of u into e raised to I lambda u du. This is formula find Fourier transform of the function. Okay. Now Fourier sine transform. Next term is Fourier sine transform. If a function is defined in the interval minus infinity to infinity and it is an odd function, f of x is defined in the interval minus infinity to infinity and it is an odd function of x, then from the expression of Fourier sine integral, the formula to find the Fourier sine transform is here f of s lambda, f suffix s is for sine transform. This lambda is equal to integration or 0 to infinity f of u sine lambda u du. Then the inverse Fourier sine transform is given by the formula f of x is equal to 2 upon pi integration or 0 to infinity fs lambda into sine lambda x d lambda. Means to find the inverse Fourier transform, inverse Fourier sine transform, we require the Fourier transform, Fourier sine transform. And then we can find its inverse Fourier transform. See here, fs lambda gives the Fourier sine transform of f of x, and f of x gives the inverse Fourier sine transform of fs lambda. That suffix s is for sine transform. Okay, so these are the two results of Fourier sine transform and inverse Fourier sine transform. Now next concept is Fourier cosine transform. If a function f of x is defined in the interval minus infinity to infinity and it is an even function of x, then from the expression of Fourier cosine integral, here we can write the formula fc lambda c. Fc lambda suffix c is for cosine transform. It is the formula for cosine transform is equal to integration for 0 to infinity f of u cos lambda u du. Then f of x is equal to 2 upon pi into integration for 0 to infinity fc lambda into cos lambda x d lambda. This is inverse Fourier cosine transform. Here fc lambda gives the Fourier cosine transform of f of x and f of x gives the inverse Fourier cosine transform of f of x. So these are the results for cosine transform and inverse Fourier cosine transform and inverse Fourier cosine transform. Okay. Now the examples on Fourier transform. Here discuss three results. First one is for general function, which is neither even nor odd. For that function, the formula to find the inverse, sorry, the formula to find the Fourier transform is here. F of lambda is equal to integration minus infinity to infinity f of u e raised to minus I lambda u du. This is the formula to find the Fourier transform when function is neither even nor odd. Then the formula to find the inverse Fourier transform when it is neither even nor odd. It is f of x is equal to 1 upon 2 pi integration over minus infinity to infinity f of lambda into e raised to I lambda x d lambda. Okay. The next is Fourier sine transform. When function is odd function, then the Fourier transform is called Fourier sine transform. Its notation is fs lambda f suffix s lambda. And the formula is integration over 0 to infinity f of u sine lambda u du. And inverse Fourier sine transform, its formula is f of x is equal to 2 upon pi into integration over 0 to infinity fs lambda into sine lambda x d lambda. Okay, next Fourier cosine transform, its formula is fc lambda f suffix cc for cosine transform. It is equal to fc lambda is equal to integration of 0 to infinity f of u cos lambda u du. And then the inverse Fourier cosine transform, its formula is f of x is equal to 2 upon pi into integration of 0 to infinity fc lambda into cos lambda x d lambda. Okay, so there are three concepts: Fourier transform, Fourier cosine transform, Fourier sine transform, and their inverses. So there are total six results. Now the examples based on these six results. The first example is here. Find Fourier cosine transform of f of x is equal to, function is defined into intervals, is equal to cos x when x is in between 0 to a, and if the function value is 0 when x is greater than or equal to a. Now we are going to find the cosine transform. Here directly the heading is find Fourier cosine transform. So no need to check whether it is even or odd. You just find the Fourier cosine transform. Now the formula for Fourier cosine transform is fc lambda f suffix c lambda is equal to integration over 0 to infinity f of u cos lambda u du. Now, what is the function here f of u? Here function is in the form of x, means variable is x in the given example. You just replace that x by u, then you will get f of u. It is f of u is equal to defined into intervals. Function is defined into intervals. It is cos u when u lies between 0 to a. So you split the integration over 0 to infinity because a is the point of discontinuity. So 0 to a and a to infinity. So epsilon lambda is equal to f of u. F of u here is cos u. Cos u in cos x, you replace that x by u, so that you will get cos u. So your function f of u is cos u when limits from 0 to a. Cos u into cos lambda u. Now multiply and divide the term by 2. Here we are multiplying by 2, so divide it by 2 also, so that you will get your original function. Plus integration for a to infinity. When limits are a to infinity, the function value is 0. So the second term is 0. Now we are multiplying and dividing the term by 2 because we are going to use here the formula 2 cos a cos b. See, what is the formula for 2 cos a cos b? It is cos of a minus b plus cos of a plus b. So cos of a minus b is here. Cos of a minus b. A is here lambda u, b is here u. So lambda minus 1 into u is common, plus cos of a plus b means lambda u plus u is common, so in bracket lambda plus 1. So this is the product formula 2 cos a cos b. We are using to split this product cos u into 2 cos u cos lambda u. So 1 by 2 as it is. In the bracket integration over 0 to a 2 cos a cos b 2 cos u cos lambda u, its value is cos of lambda 1 minus lambda 1 minus 1 into u plus cos of lambda plus 1 into u. Let it complete into du. Now there are two terms, you separate both the terms and then integrate 1 by 2 as it is. What is the integration of cos function? The integration of cos function is sine lambda minus 1 into u upon lambda minus 1 plus again second term is cos function. The integration of cos function is sine lambda plus 1 into u upon lambda plus 1. Because the integration is with respect to u, so variable is u. And so lambda in first integral, lambda minus 1 is a constant term, and in second lambda plus 1 is a constant term. So you write the coefficients in denominator while integrating, and the limits are 0 to a. So fc lambda is equal to 1 by 2 into. Now put upper limit a. Now variable is u because integration differential is here du. So integration is with respect to u. So you replace the variable u by upper limit a. So sine lambda minus 1 into u, you replace that u by upper limit a. Sine lambda minus 1 into a upon lambda minus 1 plus sine of lambda plus 1 into a upon lambda plus 1. Lower limit is 0. So put u is equal to 0. Sine 0 is 0 plus sorry, lower limit is 0. So give negative sign for lower limit. Minus sine 0 is 0. Again second term negative sign minus sine 0 0. So when we put lower limit 0, we are getting both the terms zeros. So your answer is here. Fourier cosine transform is 1 by 2 inside the bracket sine of lambda minus 1 bracket complete into a upon lambda minus 1 plus sine of lambda plus 1 into a upon lambda plus 1. So this is your answer. Now the example number 2. Find the Fourier sine and cosine transform of the function f of x, which is defined in 3 intervals. It is equal to x function is x when x is in between 0 to 1. The function is 2 minus x when x is in between 1 to 2, and the value of function is 0 when x is greater than 2. So there are 2 points of discontinuities, 1 and 2. Now we are going to find sine and cosine transform for the function. We are going to find both the transforms. So first Fourier sine transform, and the formula is fs lambda suffix s for sine transform, it is equal to integration of 0 to infinity f of u sine lambda u du. Now the function is defined in three intervals, and 1 and 2, these are the points of discontinuities. So you split the integration from 0 to 1, then 1 to 2, and then from 2 to infinity. Now from 0 to 1, the function f of u. Now we want a function f of u because inside the integral the variable is u, and the given function is in the form of x. Here the variable is x in the given example. So we just replace that x by u so that you will get f of u. When if we are replacing here x by u, then the function f of u is equal to u 2 minus u and 0. See, f of u is equal to u when u is in between 0 to 1. So 0 to 1, the function f of u is u into sine lambda u du plus from 1 to 2. From 1 to 2, limits are 1 to 2, function is 2 minus u. So replace f of u is equal to 2 minus u into sine lambda u du plus the third integration from 2 to infinity. So the function is 0, so the third term is 0 here. Now when you solve these two terms, integrate the first two integrations. Fs lambda is equal to integration u sine lambda u du. Now to solve this integration u into sine lambda u, you use here u into v rule. Now you know u into v rule. You choose u, the function u as which derivative vanished earlier as compared to other. Here derivative of u vanishes earlier as compared to sine function. So you choose u as u and sine lambda u as v. So first term u as v, sine lambda u, its integration is minus cos lambda u upon lambda, because integration is so variable is u here, lambda is constant. So in first term u as v, inside the bracket, the integration of sine function is minus cos lambda u upon lambda minus. Now derivative of u with respect to u is 1, so in bracket 1. In other bracket, the integration of this minus cos lambda u upon lambda. Integration of minus cos lambda u upon lambda is minus sine lambda u is there, so lambda into lambda, lambda square. And the limits are 0 to 1 here. So this is 1. Plus second integration is from 1 to 2. And again here you to 0 for this integration. 2 minus 2 to sin lambda u. U into u, here u is here 2 minus 2 because it's derivative mentioned earlier as compared to the derivative sin function. So 2 minus u as it is. Integration of sin function is minus cos lambda u upon lambda minus the derivative of 2 minus 2 is minus 1. So write in bracket minus 2 into integration of cos function minus cos lambda u upon lambda minus sin as it is. Integration of cos function is sin lambda u upon lambda. Already lambda is there, so lambda into lambda is lambda square. And next term 0. Then putting this 1. Next term 0 here and putting first term because u is derivative is 1 and in next term the derivative of 1 will be 0. So no need to write the next term. Similarly here in second term also minus 1 derivative of 2 minus u is minus 1 and the derivative of minus 1 is 0. So no need to write the next term. And for second term the limits are 1 to 2. Now put the limits for first and second term. In first term upper limit is 1 and variable is u, so you replace u by 1. So u is equal to 1, so u is equal to 1 minus cos lambda upon lambda minus minus plus sin lambda upon lambda square. Lower limit is 0, so put u is equal to 0. If we put u is equal to 0, first term 0 minus minus a plus, but again minus sign for lower limit, so the minus sign is there. Sin 0 is 0, so the second term is 0. Okay. Now the second term is here. Limits are 1 to 2. Upper limit is 2. Put u is equal to 2. So 2 minus 2 0. So this first term is 0. Minus minus plus. Again minus sign for sin function. So here minus sign is there. Now u is 2. So sin 2 lambda upon lambda square. This is the term here. After putting upper limit 2 here in this second term. And then lower limit is 1. For lower limit is u negative sign to every term now. Minus of now u is 1. So 2 minus of u 2 minus 1 is 1. This minus sign minus minus plus. So this sign is here plus. Minus sign of lower limit and minus sign of this first function. So minus minus plus. 2 minus 1 is 1. Cos lambda upon lambda. Because we are putting lower limit 1, u is equal to 1. Okay, so the term is cos lambda upon lambda. Next term minus minus plus, minus sign is for sin function and minus sign of lower limit. Minus minus again plus, and lambda is equal to, sorry, u is equal to 1 because u is variable. So the term is sin lambda upon lambda square. So after putting limits we have this term. Now simplify it. Minus cos lambda upon lambda plus cos lambda upon lambda get cancelled. Then sin lambda upon lambda square plus sin lambda upon lambda square is 2 times sin lambda upon lambda square minus sin 2 lambda upon lambda square. So this is hs lambda is Fourier sine transform. Now we know that sin 2 lambda 2 sin 2 theta is 2 sin theta cos theta using the same formula. In place of theta there is lambda, so the formula is sin 2 lambda is 2 sin lambda into cos lambda. So put here sin 2 lambda is equal to 2 sin lambda cos lambda. So put this value here, then denominator is same, so we can do the addition of numerator, subtraction of numerator. So fs lambda is equal to 2 sin lambda common in bracket 1 minus cos lambda upon lambda square. So this is your answer, that Fourier sine transform is here. Now in this example we have to find out both the transform, sine transform as well as cosine transform. Now this is Fourier sine transform, and cosine transform you can find the Fourier cosine transform. You know the formula, fc lambda is equal to integration of 0 to infinity f of u cos lambda u du. Now here f of u is the function is defined in 3 intervals, 0 to 1, 1 to 2, and then 2 to infinity. From 0 to 1, the function f of u is u here. Actually, the given function is defined and the variable u is x there. But you just replace that x by u, then you will get f of u. From 0 to 1, the function is u into this first function as it is cos lambda u du plus. Now from limits 1 to 2, in the interval 1 to 2, the function defined is 2 minus u, and the first function as it is cos lambda u du plus from integration from 2 to infinity, the function is 0, so third term is absent here. There are only two integrations, 0 to 1 and 1 to 2, like the sine transform. And you just solve the integration like the sine transform. Here we have done the same steps here. So solve the integrations to find the Fourier sine transform. Similarly, you solve the two integration terms. See, use here u into v rule again. U first integration u is u and v is cos lambda u. So u as it is. Integration by parts rule, we have discussed this rule in first unit already. So you know the general formula to find the integration when there is product of two functions, general UV rule. Discuss it previous means unit number 1. So you know the formula u into v. Here the u, the function whose derivative vanished earlier as compared to other, that function is u. Here the function u is u variable. So u is equal to u. V means integration of v function is cos lambda u. Integration of v means integration of cos function is sin lambda u upon lambda, because variable is u. Lambda is constant. So integration of cos lambda u is sin lambda u upon lambda minus. Now derivative of u is 1. So write here 1. Integration of sin lambda u upon lambda is minus cos lambda u upon lambda. Already lambda is there, so lambda into lambda, lambda square. This is the integration of first term, limit 0 to 1. Similarly, the integration of second term, here use here u into v rule. U is here 2 minus u and v is cos lambda u. So integration of cos function is sin lambda u upon lambda minus. Now the derivative of 2 minus u is minus 1. So right here minus 1. Integration of sine function sin lambda u is minus cos lambda u upon lambda. Already lambda is there in denominator, so lambda into lambda, lambda square, and limits 1 to 2. Now put the limits like the previous one, and then you will get this answer: 2 cos lambda upon lambda square minus cos 2 lambda lambda square minus 1 upon lambda square. To simplify, denominator is same, so directly we can add the terms. So 2 cos lambda minus cos 2 lambda minus 1 upon lambda square. So this is your answer. Fourier cosine transform. Here the notation is, there is one correction. This connection here. This is this correction here. Okay. The notation is not, suffix is not s, the suffix is c. Fc lambda is equal to 2 cos lambda minus cos 2 lambda minus 1 upon lambda square, because for cosine transform, so we use the notation Fc lambda, Fc f suffix c into lambda. Okay. This is one correction here. And here the concept Fourier transform and the example based on Fourier transform. The first part is over here. Thank you.